of 1 is 1, then it completes its execution. This function first completes its execution. Okay, its execution is completed. Okay, then what we will do? It will go back to fib of 3. Here it will come back. Then it will go to here fib of 2. Then what fib of 2 will do? It will again call fib of 0 and fib of 1. Fib of 0 and fib of 1. Then this so anyway in this way it will work. Okay, so this is the corresponding recursion tree. Okay, you can note here, this is the corresponding recursion tree. Okay. This is the corresponding recursion tree. So my question is, how many recursive calls are there in this tree? Okay, I am not having the lab connection, so some presentation problem. Anyway, I will tell the concept. You can note here, this is the recursion tree corresponding to the fib of 5. Okay, so my question is, how many recursive calls are there? How many recursive calls are there? Just to count the number of nodes, fib of 5, fib of 3, in this way. So if you count it, then you will get the answer. Total number of calls is equal to 15. Okay, you can note here, total number of calls is equal to 15. So just to count the number of nodes in the tree. Okay, just to count the number of nodes in the tree, and it is 15, 1 5. Okay, so there are 15 calls are made. There are 15 calls are necessary for solving this problem. Okay, so okay, so what we will do next? Next, this is the recurrence equation corresponding to the problem. Okay, T of n equal to 1 if n less than or equal to 1, else we will call 2 into T of n minus 1 plus 1. Okay, 2 into T of n minus 1 plus 1. Why 2 into T of n minus 1 plus 1? Here, fib of 5 is calling fib of 3 and fib of 4. Then it again, fib of 3 will call fib of 1 and fib of 2. So these two calls are there, fib of n minus 2, fib of n minus 1. So that is why this is 2 into T of n minus 1 plus 1. Okay, 2 into T of n minus 1 plus 1. So, okay. So, if you solve it using any of our methods, substitution method or recursion tree method or Master's theorem, if possible, we can apply. I think it's not possible to apply Master's theorem here. Okay, so you can use substitution or recursion tree method, and after solving it using that, you will get the complexity is big of 2 raised to n. Okay, big of 2 raised to n is the complexity. Big of 2 raised to n is the complexity. Okay. Okay. So, what is the disadvantage associated with this problem? So, it needs to execute overlapping subproblem. Okay. So, what is overlapping subproblem? What is meant by overlapping subproblem? So in this figure you can note, here you can note, here I'm just moving to that portion. In this tree, fib of 2 is there. Okay, fib of 2 is there. Then fib of 2, so fib of 2 is fib of 0 plus fib of 1. Okay, fib of 2 is fib of 0 plus fib of 1. And if you note this, in this tree, here also fib of 2 coming. Okay, fib of 2 in this part also coming. Fib of 2, fib of 0 plus fib of 1. So basically, if you think about this tree, here you can note a fib of 2. Here also you can note fib of 2. So this subproblem fib of 2 executed 2 times in this tree. 2 times in this tree. So that is called overlapping subproblem case. Okay, that is called overlapping subproblem. Because of this overlapping subproblem, this overlapping subproblem, these much calls came. Okay, these much calls came. That is okay. So that is the disadvantage of this method. Need to execute overlapping subproblems. What is overlapping subproblem means? In the same recursion tree, a function, a subproblem is executed 2 or 3 times, more than 1 time. That is called overlapping subproblem. Okay. So how can solve it? Okay, 1 minute. I will come back. I think net is connected. Okay, please wait. Okay. ഓക്കെ, അപ്പോൾ ഓവർലാപ്പിംഗ് സബ് പ്രോബ്ലം എന്ന് വെച്ചാൽ, അതായത് നിങ്ങളുടെ റിക്കർഷൻ ട്രീ നോക്കുകയാണെങ്കിൽ ആ ഒരു റിക്കർഷൻ ട്രീയിൽ മോർ ദാൻ 1 ടൈംസ് ഒരു പെർട്ടിക്കുലർ സബ് പ്രോബ്ലം എക്സിക്യൂട്ട് ചെയ്തിട്ടുണ്ടാവും. അതായത് അത് സെയിം ഫങ്ഷനാണ് പെർഫോം ചെയ്യുന്നത്, ബട്ട് ഇറ്റ് ഈസ് എക്സിക്യൂട്ടഡ് മോർ ദാൻ 1 ടൈം. അപ്പോൾ അതിനെയാണ് ഓവർലാപ്പിംഗ് സബ് പ്രോബ്ലം എന്ന് പറയാം. ഓക്കെ, ദാറ്റ് ഈസ് ഓവർലാപ്പിംഗ് സബ് പ്രോബ്ലം. So, by solving that overlapping subproblem, we can improve the algorithm. Okay. Okay. Please wait. Okay. So, by solving the overlapping subproblem, we can improve the algorithm. അതായത് ഓവർലാപ്പിംഗ് സബ് പ്രോബ്ലം സോൾവ് ചെയ്യുകയാണെങ്കിൽ നമുക്ക് എന്ത് ചെയ്യാം, ഇപ്പോഴത്തെ ഈ 15 കോൾസ് ആണ് ആ റിക്കർഷൻ ട്രീയിൽ വരുന്നത്, അത് റെഡ്യൂസ് ചെയ്യാൻ വേണ്ടി പറ്റും. ഓക്കെ, സോ നെക്സ്റ്റ് 1 minute.
ഓക്കെ, നമ്മളിപ്പോഴും ഓവർലാപ്പിംഗ് സബ് പ്രോബ്ലം എന്താണെന്ന് ഡിസ്കസ് ചെയ്തു. നെക്സ്റ്റ്, so you can note here, to solve this problem, dynamic programming based approach can be used. Okay, so to solve this problem, dynamic programming
Okay. Hello. Hello. Anaka, okay ആണോ?
Sir, okay.
Okay. 1 minute. Okay. Okay. So we discussed this Fibonacci series. Then the approach used to solve using divide and conquer approach. Okay. So I'm just discussing one more time. Okay. So you can note here. Okay. So this is the regression tree corresponding to fifth element. Okay. So what will happen is that initially it will start from fib of 5. Okay. Initially it will start from fib of 5. Then it will call this one, this function, okay, this function and this function. Then which function get executed next? This one is executed. Okay, then it will call fib of 1. Okay, this problem is solved. Okay, fib of 1 is the base case, so fib of 1 will return the result back to its parent. Okay, fib of here. Then what will happen next? So then it will call this one. Okay, so fib of 2 is called. Okay, then it is executed. Then it will call fib of 0. Okay, fib of 0. Then the result is returned back to here. What is fib of 0? It is 0. Okay, fib of 0 is 0. In this way, this regression tree will work. Then it will call, this will return 0. This is 0. This is 1. So this will return 1 here. Okay. Then this is 0 and this is 1. 0 will return back to here. This is 0. Then it will call 1. This will return 1. Then it will perform 0 plus 1. Okay, 0 plus 1. What is 0 plus 1? 1. Okay, then it returns 1 back to here. 1 is returned back. Here 1 is there. 1 plus 1 is 2. And 2 is returned back to here. Okay, 2 is returned back to here. Okay, this is 2. 2 is returned back to the parent. Then the parent is fib of 5. What it will call? Which function? This will call this function. This is executed. Then this will call this function. In this way, it will work. Okay. Okay, I will tell how it is work. So then it will call this one fib of 2. Okay, then it will call fib of 0. Okay. So fib of 0 is 0. So this completes its execution. Okay, this completes its execution. Then return back which value? 0. It will return back 0. Similarly, then it will call fib of 1. Okay, what is fib of 1? 1. So it returns back 1. 0 plus 1 is 1. Now it returns back 1. So 1. Then it will call this one. Okay, so basically this is 1, this is 2 now. Okay, 2 and 1 is there. So it will call this function fib of 3. Okay, fib of 3. Then it will call fib of 1. Then 1 is returned back. So this is 1 is returned back. Okay, in this okay, anyway, this is 1 and fib of 2 is called. then fib of 2 will call fib of 0. Fib of 0 will return 0. Then 0 plus 1, this is 1. 1 plus 1, it is 2. Then 2 is returned back. 2 plus 1, it is 3. And 3 is returned back. 3 plus 2, it is 5. Okay. We'll get 5 is the answer. Fib of 5. Okay. In this way it will work. Just analyze the working. Anyway, the concept is that I hope you can hear. Okay. Okay. Hello, Anaka. Okay, man.
Sir, okay.
Okay. So, you can note here, this is fib of 2. Okay, this is fib of 2. This function, this is a subproblem. This subproblem is also executed here also. Okay, fib of this function. You can note here. Similarly, fib of 2 is executed here also, but all produces the same result. Yeah? Fib of 2 perform 0 plus 1, 1. 0 plus 1, 1. This is 1. All are performing the same thing, but it is executed always. So we want to prevent this. If we prevent this, then number of calls can be reduced. Then efficiency of the program can be improved. Okay, so that is we are trying to do it now. Okay, so this is called overlapping subproblem. So I hope you got the idea what is overlapping subproblem. To solve the problem, dynamic programming based approach can be used. That is, the result of the subproblem, you can note here, the result of the subproblem stored. Okay, stored and reused. So memoization is used. That is, the result of a subproblem is stored and reused. Okay, that is dynamic programming based approach or memoization. This concept can be applied here. Okay, so we are slightly modifying the program in this way. Okay, so fib of n, if n less than or equal to 1, I'm using an array f. Okay, I'm using an array f. Additionally, I'm using an array f. Okay, f is considered as a global array. Okay, f is considered as a global array. Then, if f of n is not equal to -1, then return f of n. I'm adding additionally these two. Okay, to our program. Then here a global array store the result. Okay, in this way I modified the program. Okay, so what will happen? So basic concept is simple. I'm additionally adding an array f to store the intermediate result. Okay, so you can note here f is the global array used for storing the intermediate results. Okay, so what is f of n? F of n is an array used to store the intermediate results or Fibonacci number, that is for memoization. For memoization, for implementing memoization, I am additionally adding an array f. Okay, it is a global array, which means we don't want to pass it to the function. Okay, so it is assigned as a global array and it is initially assigned like this. Okay, initially f is assigned with all -1. Okay, so next what will do? Okay, so in this case, how this tree will work? You can analyze. Initially, fib of 5 is called. Okay, initially fib of 5 is called. Fib of 5 is called fib of 3 and fib of 2. Okay, then which one will be executed? Which one will be executed? Fib of 3 will be executed. Okay, so okay, so next which will be executed? This one will be executed. It will call two function. This one and this one. This one is executed. So fib of 1 is the base case. Okay. If I reach the base case, what I will do? You can note here. I will update this f. Okay. I will update with its f. That is, in this position 1, I will store the value. Okay. So you can note here. This is I am doing. this is I'm doing. You can note here this one, this get executed. That is, if it is a base case, what I will do is that I will store the value 1 or 0 in this array corresponding to that position. F of n is equal to n. Okay, f of n equal to n. Then in the global array, in this position, -1 will be replaced with 1. Okay. Then what I will do? I will go back. Okay. I will go back to the parent. Okay. Then the parent will then call this one and this get executed. So then what will it call? It will call fib of 0 again. Okay. It will call fib of 0. Fib of 0 is the base case. It will update 1. Okay. Already it is updated, just I am updating it, no problem. Now it will, the value is returned back. Okay, now I reach it back here, then I will call this one. Okay, fib of 1. Oh sorry, this is fib of 0. Okay, so what I will do, I will update this value. This value I update in the f I update this one. Okay, then fib of 1. Okay, fib of 1, it is already updated. This value is already updated. Okay, then I will return back. Return back and I reach it here. Here what I will do, you can note the code. F of n is equal to fib of n minus 2 plus fib of n minus 1. So after I returned back, here this is updated. This position is updated with what? This is 0 returning, this is 1 returning, 0 plus 1 is 1. Okay, then I return back. I return back to here. Here fib of 1 is 1. Here it is 1. It is now it is 1. 1 plus 1 is 2. Then this is updated. Okay, this is updated. Okay, then I will go back to here. Okay, then I will go back to here. Okay, then what will happen is that I will go back to here. Then I will call fib of 4. This is executed. Okay, this is executed. Then fib of 4 will call fib of 2 and fib of 3. Okay, fib of 4 will call fib of 2 and fib of 3. Then this is executed. But you can note here fib of 2. Okay, what is fib of 2 is called? It will work in this way, 2 less than or equal to 1, no. So this code will not be executed. Next, if f of 2 not equal to -1 or f of 2 equal to -1. So in this case, now the situation is, you can note f of 2. What is f of 2? F of 2 is 1. Okay. In the array f, it will check the value corresponding to 2. F2, this is checked. It is 1. So what it will do, it will not call other functions. Then it will just return back. Okay. So what will happen is that, so below this no calls are executed. Okay, below this no calls are executed. Okay. Anyway, this is happening. So these calls, below this there is no calls. Similarly with fib of 3, below this there is no calls. Okay. So you can note here these unnecessary calls. These are completely eliminated from there. These are completely eliminated. Okay. So the number of calls is reduced. Okay. The number of calls is reduced and the number of calls needed is now 9 only. Okay. So basically the complexity is big of n. Okay. The complexity is big of n. Okay. So this is our approach. Another approach is iterative dynamic programming based algorithm that uses memoization. That is, we are storing. This is an iterative method. We are solving the problem in this way. F of 0 is 0, f of 1 is 1. Then we will use a for loop. Then we will use this equation. F of I is equal to f of I minus 2 plus f of I minus 1. Then this is complete. This is a very simple program. We can solve this program also using this method. This is called iterative dynamic programming based algorithm. initially f of 0 will be 0, f of 1 will be, when I is equal to 2, it is updated. 0 plus 1 plus 1. That is good. Okay. Anyway, in this way it will work. This is about the iterative dynamic programming based anyway, okay. Please give your attendance. Okay. You can give your attendance in the chat box. Okay.